Which of these Lewis dot structures shows the correct configuration of boron? Remember that the dots around each letter represents valence electrons. Each letter represents an atom of a specific element. You can find these elements on a periodic table. The number of valence electrons that each element has is based on its position on this periodic table. So what you have to do is figure out which configuration is the correct one for boron. I'll give you a hint, look at the different groups in the periodic table. So which of these atoms is the correct configuration? The bottom right one here is the correct configuration since boron has 3 valence electrons. Let's do another one. Which configuration of chlorine is correct? First, remember we have to look at the number of valence electrons chlorine has. Try to find it on the periodic table. I'll give you a hint, it's on the right hand side. Chlorine is here, which means it's in group 7. That means it has 7 valence electrons. Alright, so which configuration is correct? Again, all you have to do is count the number of valence electrons around chlorine, and this top right one is the correct one since there are 7 valence electrons. Alright, last one, here's the tricky one. Which configuration of helium is correct? Try to find helium on the periodic table. I'm not going to give you a help this time. Remember, helium's tricky. So which one of these atoms is correct? So I would actually accept 2 correct answers here. The top one, helium here, and this right one, helium here, are both correct. This is because helium has 2 valence electrons. And in this case, for helium, they can be paired or they can be unpaired. So I would honestly accept either of these choices as the correct answer.